Now we've been studying and trying to understand the feedback loops that are happening in the Arctic. So we know that the ice is melting. We know that there is water that is then, of course, being produced by the melting ice. And we want to know what that means. Why does that mean that the speeding up of the melting of the ice? Why is that? And one of the key concepts we're talking about here is albedo. Now this word albedo may be a little bit strange, but we know this word basically means white. It means like albino means white. And it means white because we're dealing with something white. We're dealing with ice, and the ice melts and it turns into water, which we actually think of as being black. Of course, let's actually start with the definition of albedo. So albedo is the amount of light reflected off of a surface. The amount of light reflected off of a surface. So the surface we're dealing with here is the surface of the Earth. Now, of course, the Earth has land and all the things that come with that, but it also has water and ice, and we're dealing really with water and ice. So I'm going to go ahead and draw a picture of both. We've got the left-hand side, which is ice, and we've got the right-hand side, which we're going to call our water side. Now what happens? We have light coming from the sun. This is going to be true no matter whether we're dealing with ice or water. We have light coming from the sun, and two things can happen to that light. One, it can be absorbed. Absorbed light is also called heat or infrared light. So that can happen on either side. It can also be reflected, and that also can happen on either side. So we've got reflected, and we've got reflected on the water, except it's a little bit different. The ice, which we've represented by the white and as more reflection, reflects about, say, 35% of the light. On the other hand, our water reflects about, say, 7%. It's quite a big difference there. Now, we should notice that there actually is still more light that is absorbed. So if we have 35% of light reflected, we have then 65% absorbed as heat. On the other side, of course, now we have 93% absorbed as heat. This is also called infrared, and I'm going to just label that so that we remember that it's also called infrared light. So to recap, we have incoming light, and of course there's 100% of that total. On the other side, of course, we still have 100% incoming light. But on the water side, we've got 93% absorbed, and that is absorbed heat. So that's heat that's still sticking around. And then we've got 7% reflected. On the ice side, we've got 65% absorbed as heat and 35% reflected. So I hope that you can see that there's quite a big difference there.